Okay, now we are going to look at the stoichiometry. Stoichiometry is a quantitative study of reactant and product in the chemical reaction, where a chemical reaction can be interpreted in the terms molecule, mole, mass, or even volume. Okay, let's look at this example. How we are going to read this equation is 1 mole C3H8 pentane is combusted completely in oxygen, produce 3 more carbon dioxide and 4 more water. So here you can look at there are 1 molecule of C3H8, 5 molecule oxygen, 3 molecule carbon dioxide and 4 molecule. Okay, so if you look at here, 1 molecule of pentane react with 5 molecule of oxygen to produce 3 molecule of carbon dioxide and 4 molecule of water. Or in other way, you may say that there are 6.02 times 10 to the power 23 molecule of pentane react with 5 times 6.02 times 10 to the power 23 molecule of oxygen to produce 3 times 6.02 times 10 to the power 23 molecule of carbon dioxide and 4 times 6.02 times 10 to the power 23 molecule of water. Either way, it is either you are talking about molecule or particles of the molecule of pentane. Both we can explain. Okay. Or you may say that 1 mole. If you are read this as a 1 mole of pentane, so it will react with 5 mole of oxygen, 3 mole of carbon dioxide, 4 mole of H2O. Okay, this is in gram. Okay, and if you are multiply the equation by 5, all is multiplied by 5. Okay, but I'm going to highlight for this one. At room condition, okay, the condition is 25 degrees Celsius. This is temperature. And the pressure is 1 atm. 24 dm cube of pentane will react with 5 times 24 dm cube of oxygen. It will produce 3 times 24 dm cube of carbon dioxide and 4 times 24 dm cube of oxygen. Why this is happen? Because at room condition, 1 mole of any gases will occupy 24 dm cube container. So here pentane is a gas, oxygen is a gas, CO2 is a gas, and water is a gas. So 1 mole occupied 24 dm cube container. This is 5 times 24 dm cube container, size of container. Okay. Okay, let's look at the example number 1. How many grams of water are produced in the oxidation of 0.125 gram glucose? Here we have 0.125 mole of glucose. Okay, the question asks us to find out mass water. So, if you look at from balance equation, 1 mole glucose C6H12O6 will produce 6 mole water. So, if we do have 0.125 mole C6H12O6 will be produced 0.125 divided by 1 times 6. Therefore, number of mole of water produced is equal to 0.75 mole. Okay. Then, in order to find out mass, therefore, mass of water is equal to 0.75 times molar mass is 18 gram per mole. Then we got 13.5 gram. Okay, now let's look at the limiting reactant. Limiting reactant is the reactant that is completely consumed in the reaction and limit the amount of product formed. While excess reactant is the reactant that remain after the reaction, okay, and then it present at a greater quantity compared to the limiting reactant. Okay, let's look at ice cream here. If we do have 12 ounce, where it is 2 scoop of ice cream and 1 cherry, okay, and then 50 ml syrup, we will make 1 sundae cone. Okay, but if you look at to the situation B here, we do have 8 scoop of ice cream, 6 cherry, and we are only have 100 ml syrup. We are only able to make 2 sundae cone. In this case, ice cream is the excess reactant, cherries is also excess reactant, while syrup is a limiting reactant because 1 sundae cone need 50 ml syrup, 2 sundae cone need 100 ml syrup. If we are going to use all the ice cream here, we have 1 sundae cone need 2 scoop of ice cream. Here we have 8 scoop of ice cream. We can make 4 sundae cone. But we are only have 100 ml syrup. If we are going to make 8 sundae cone, if we are going to make 4 sundae cone, so we will need 200 ml syrup. Okay. So, in order to determine the limiting reactant, we have 2 methods. Okay, method 1, you need to calculate mole of the reactant present. After that, you choose one of the reactant and anticipate the mole needed theoretically for the other reactant. If the amount of the reactant present is less than the one needed theoretically, thus the reactant is the limiting reactant. Okay, method 2, you can calculate the moles of the reactant present. After that, deduce the mole of a product that will be formed by each of the reactant. Then the reactant that produce less amount of the product, limit the product, is the limiting reactant. The other reactant is considered in excess. Okay, let us consider this example. Okay, if we do have zinc solid react with HCl, we have produced zinc chloride and H2 gas. If we need 2 mole of zinc, okay, if 2 mole of zinc will mix with 3 mole of HCl, determine the limiting reactant. So how we are going to answer this one? So from the equation, we are look at 2, there are 1 mole of zinc. We have 1 mole of zinc here, react with 2 mole of HCl. So we do have 2 mole of zinc. If we do have a 2 mole of zinc, it will react with 4 mole of HCl. But if you look at here, there are only 3 mole of HCl. Therefore, number of mole of HCl given is less than number of mole of HCl needed. Therefore, the limiting reactant is a HCl, while zinc is the excess reactant. Okay, last part, theoretical and actual and percentage yield. For theoretical yield, the maximum amount of product. Okay, if you look at here, theoretical yield refer to the maximum amount of product which is calculated using the balance equation. Actual yield, this is from balance equation. The actual yield is the amount of product obtained when the reaction takes place. This is we got from the experiment. The theoretical we got from the equation. The actual we got from the experiment. So how we are going to calculate the percentage yield is the ratio of the actual yield to the theoretical yield. It is actual. We are compared to the theoretical time 100. This is the formula how we are going to calculate the percentage yield. Divided by theoretical yield.